Hello guys, we have learned the overview of AI and the math, the basics, TensorFlow, and now we will start to learn the important part, deep learnings. Before we learn it, we should know some basics in machine learning knowledge, such as what is the learning algorithms and common machine learning algorithms and other some important knowledges. After that, you will understand deep learnings better. Let's get a quick start of it. As we all know, machine learning is the core technology of AI, and deep learning is a subset of the machine learning. So what's the machine learning? Machine learning is the study of the learning algorithms, and a computer programs learn knowledge from the appearance E, and we finished the test and T, and used the performance P to measure the result is good or not. As a measure by the P and is a performance, and the performance improved with appearance E. So to compare the human learnings, and we can see the computer uses data as appearance, use learning algorithms as a task, and as the learning results and understandings and its prediction as its performance. So let's compare and the human and our computer learning process for some details. People learning from appearance and results from the law, and also when he faced the new problems, and he will have the prediction. He learning the things from the the computers. He learning the things from the historical data, and the rules will be saved in the model. And if the new problems come, and if the new data comes, and first convert the problems into data, and then use the model to solve it. For example, if we predict tomorrow weather, experienced people judge it if it will rain or not for seeing the size of cloud or the number of the clouds. But for the computer, it can't predict the weather like this. He will use the 2 or more years the data, and the data will include many factors like wet, temperature, cloudy or not, season, and so on, and use the model to summarize the relationship between the weather and the factors. And then we use the model to predict tomorrow's temperature or tomorrow's weather. It's the process of the computer finished our test. And the data set is we used to finish the task. The data set include samples and the features. Each samples have the group of features, and the data may like that. We have maybe the many samples. This is our sample. This is the features. These features factors our samples result label. Maybe in the last column is the label. The last columns is maybe a label. If we predict our weather, it's raining, yes, raining or not, yes or not yes. Some based labels to present. Maybe this day is day 1, maybe some day 2, also, and so on. And these features, maybe it's wet, it's the temperature, and it's cloudy or not, and many features. So it's the data set we described that. It will is split into 2 parts: the training set and the test set. And the training set is used to train our models, and the test set is used to test our models' performance well or not. In the weather case, and the data set is a whole data. That's the whole data set, and we use it. And the features are these factors, and Weber's data features. They are the features, and we split the data may 4/5 of the data as the training data, as the training data, and 1/5 maybe as the test data to test our models. So that's the data set, training set, and test set. That's the how to split it, and maybe we can split like that. Okay, and we will introduce the generalized capabilities. And the ability is to perform well on the test sample is called the generalization capabilities. Generalize these things just for the test result. And error is the difference between the prediction and actual samples results. It contains the two sublists of train errors and generation error. So the generation error, if the generation error is very small, it means that the generation capability is very large, is very good. So, and that's kind of the test. Maybe the test, our test can split like that: the classification and the regressions. And the classification and is that regressions are two major types of the prediction task. And the classification is to do which class it belongs to problems. For example, if it rings or not, it's the yes or no. It's yes or no problems, the classification. And if it's raining, it's yes. If it's not raining, it's no. So regressions is therefore to predict the trend of the problem and to change the temperature and the price of the house. Let's see the examples of the temperature change. If there is maybe the D1, maybe the D2, okay, and the next D3. Maybe it's D1, its temperature is 24, and D2 the 23, maybe the temperature like that. So we will use the history data and to predict the trend of the temperatures. Maybe the history data is about 2 years or 3 years and more years the data is about the temperatures and some factors to affect the temperatures. And that's regressing programs. So the outputs of the classification and are the discrete types of values, and maybe it's the yes string or the not string. Is we use the 1, 0 to represent it. While the outputs of regressings are consecutive values, maybe it's the 24, it's the 25, maybe it's the 23, 26, and then 26, and it's the consecutive values. The capability of the models is the ability is to fit the widely variables to the functions. Machine learning algorithms will generally perform the best when their capability is appears for the true complexities of the task. So they need to perform standard amount of the training data they are provided with. And the model with the inference capability are not able to solve the complex task, and the model with the high capability can solve the complex task. If the model is too simple or training times is too short, it will face the underfitting problems. And underfitting problems, it fails to learn features, so we can just see a linear line can't fit the data very well. So it will face the underfitting problems, and the training error will be very large, and they see more about the test error. The test error it will be very large. The model can't learn the data well. it's quite well the model performance with its adjustment, the perfecter. If the model learns the data too carefully with many details and too carefully, if the data here and then here, if the data here, and it will regress the training like too carefully, and it will learn some noisy data and some is the dirty data. It will cause the training error. And training error is that for this data distributing as well. If I used this data, maybe like the data like that. It's the nurse is not well performance well. It will cause the overfitting problems. The model learning is too much noises, and it's just focused on the train test, but for training test, it forced the training test, and the model is just for the training data, and for the test data, it's not feature very well, and it will cause the training error is very small, and the test ledger is very large. So it's about the error. Let's see some basic terms. The first P predict example including, but in the weather prediction we use the raining as the positive examples, and we will use the number 1 to represent it. For negative examples we use n, maybe it's not raining, we use the 0. For true positive examples, that means the positive example that correctly classified by our visitor. That means the prediction is raining. The real result is also raining, so maybe the prediction is 1, and our result is also 1. It will be the TP, means that. Also the TN means that the true negative examples maybe is the not rain stays 0, and the real result is not raining. It's both 0. The positive example means that the negative examples that are incorrectly marked as the positive examples. That means that if the result maybe that's true. That's a choose. Choose is maybe like that. A choose, and this is our prediction. That means the result, the real result, the choose is the raining is the yes. Our raining is the number 1, but our prediction predict as it's not raining is the row. And so this will belong to the false positive example. And the false negative examples like that is if our is no and then it's not raining, but our prediction will predict it's raining. So we can build a confusion matrix like that and use our models and our result put into the complexes. The computers will to help us to understand the results better, and from the confusion matrix we can get many measures like accuracy and correct classification, and use the true predictions to predict to our result the summary of the result. And the error rate and the false classification like that is it maybe with this one, maybe it's the R, maybe the error is the error equal to, so the R minus the E is the equal to 1. That means that we can see some from the forums. And sensitivity, we can use the true positive rate, and also we call the recurrent. Let's just focus on the positive example. Now for negative the rate, and also we will to build the present and F score and the F lambda. That's the confusing cost management methods, and we can use the method to measure the result is good or not, and we should also judge the model is performing well or not. And let's see how to calculate this result, and let's see examples. Suppose that we have the training models to identify the cats. Now we use the 200 images to test its performance. Among these 200 images, 117 contains cats, and another doesn't contain cats. And the identification result of the model is the 15 models contains cats, and the 40 doesn't contain cats. So we can build the confusing matrix, and then we calculate like that. And if the TP means it's a positive example, it's a cat, and also we predict the prediction cat is about the 40 and 140, and it's the major cats. So for the recall accuracy, we can also confirm these characteristics to calculate like that. We should know the recall meanings, just a way to like that. The recall just a positive rate, and how about the accuracy means? So we used just the whole choose the example to display the whole results. This part we introduced some basics learning algorithms. In next video, we will learn some traditional machine learning algorithms. See you in the next video. Bye.